So just a recall and everything, because what we done in the previous class, let's do that recall sense. So that is during addition or subtraction, how many significant figures should be there in result? Significant figures Sarah, you are absent. So beta significant figures are the non-zero number for any particular measurement. Okay, and there are few rules which we need to follow to find the significant figures, and there is a scientific notation which is you can say S, and I'm going to write scientific notation is A into 10 to the power B, where A is something number and B is something number also. So that is a scientific notation, and these numbers basically, example again, the length of this particular you can say road or wire or cloth is that much. So these are something non-zero number is basically known as significant figure. More obviously you're going to understand when you go through the previous whole lecture. Clear? Okay. So while adding or subtracting, the final result obtained should have as many significant figures as present in the input value with the least significant figures. Means whatever it is saying, whenever you are doing any mathematical operation, either it is going to be addition, multiplication, subtraction, division, so the least number of significant figures you need to follow. For example, here we have 2 and 2, 4. Here we have 4 and 5. In addition, if addition is done, these two inputs that tell the result is this. However, the result should be this one, because we need to follow the least significant figure formula. So there are 4 significant figures, nothing more than that. Arithmetic operation on significant figures, that's we already done. So that is a repetition. Measurement, from here this particular lecture is started. So as we know, in measurement there are two things. First is accuracy and another thing is precision. So if you clear these two concepts in a very first manner, in a very first page, then everything is going to be easy. Is this clear? Bhuvana, Mukeshwaram, Arshita, everyone here. Okay. Good. So what is an accuracy? Let's discuss this. Accuracy is the extent to which a reported measurement approaches the true value of the quantity measured. For example, okay, exactly, that is the great example is given here. Suppose a student here having a height 5'9". Okay, but if you are measuring with the help of a tape, or you can say somewhere it is on the wall, it is mentioned like this. Okay, and you stand here. So suppose you are standing with a you can say on somewhere, or you are wearing some shoes. So then it is going to be 5.10 with the help of your shoes. Suppose if the 5'9" mark is not clearly mentioned, so someone is going to observe 5.8. So how close you are to the actual value, that is the actual value, how close you are to the actual value, that is known as accuracy. Another example we can say, how many of you play the archery game or have ever seen the archery game? So in an archery game, what the main aim of an archer is to hit the bullseye, to hit at the 10th number, or you can say 10 points. And where is the 10 point? Exactly in the between, right? Then there is 9, then there is 8, 7, 6, so and so. How far the archer is going to be hit, that is the least number. How close it is going to be hit, it is the most number in numbers, or you can say in points. So how accurate it is going to according to that particular example. Clear everyone? So suppose a man's true height is exactly 5 feet 9 inch. When it is measured with a yardstick, the value is this is 5 and that is going to be 10, not obviously. Hence the measurement is not accurate. Obviously it is not accurate because it is 5'10" or somewhere this. But the actual height is this. It can be 5'8", it can be 5'7", it can be 5'11" also. With which particular instrument, with which particular technique you are observing, that depends. Okay. Some simple measurement like how you can observe the height. In hospitals, there is a bar written on the wall. So you stand there, you can observe your height. Then there is a, in military, what they said, what they do basically in NCCs or in camp, like wherever you school going to provide or somewhere college, NCC camp basically, where you learn to how to handle, you can say, arms and how to be in discipline. Okay, so there is a measurement, 1 bar they stick, I mean apply, and then if you touch that particular bar, so that is 5.10 something. Suppose if you don't touch that, so sometimes a student is going to touch whenever he or she is, you can see, stand on his or her toe. Normal, if it is standing, so it is not going to touch. He or she is not going to touch. But if he or she is standing on his or her toe, so there is an error, because in that case that is not accurate height. Is this clear? Or sometimes the student is long enough, so he or she crossed the bar, so that is also okay. Is this clear? What is an accuracy? It is very simple thing, but when it is going to be in a definition way, so it is a little bit problematic. Now what precision is? Precision is the degree of exactness or refinement of a measurement. Basically it describes the limitation of the measuring instrument. Now what it is, for example, okay, then you're going to understand with this. Okay, suppose this is your wire. Okay, it is a wire. If you are trying to observe the radius of this wire, now try to think and then you are going to understand, because it is radius is going to be in mm, or you can say 0.034 mm. Mm means millimeter. Understood everyone? So it is somewhere 3.4 into 10 to the power minus 5 meter range. Clear? Is this clear now everyone? So if you are trying to observe this with a millimeter scale, so obviously you are going to do a mistake, and that is not accurate. Why so? Because the precision of that particular instrument is not sufficient to observe this, because it is somewhere of the order of, you can say, 34 micrometer. What is a micrometer? 1 micrometer beta is 10 to the power minus 6 meter. So if you try to observe the radius of this particular thing with a vernier caliper, vernier caliper is an instrument which have a least count. What is the least count? Which can you give the minimum value? Okay, least count is the minimum value observed by any particular instrument, that is 0.01 centimeter, or you can say 0.1 mm, which is of the order of 10 to the power 10 to the power minus 4 meter, or you can say 100 micrometer. So if it is the order of 100 micrometer, so it cannot observe 34 micrometer. So precision is going to be degraded. Clear? Understood? And you can understood in that sense also, if it is the length of your nail, or you can say the thickness of your nail, that is the perfect example. So thickness of the nail, okay, your nail, this one, girls understand better in this because they have a long, okay, the thickness of a nail is somewhere, you can say, 0 point, not 0 point, in mm, it is going to be suppose 2 mm, which is 2 into 10 to the power minus 3 meter. Now if I'm trying to observe the thickness of my nail with the centimeter scale, 15 centimeter long centimeter scale, like putting in this way, so you are not able to measure that particular length. Why so? Because that is not precise to measure that particular degree of measurement. Some advanced word I'm using, but that is the way to teach this. Degree of measurement means degree of exactness, degree of the refined particular measuring value, because it is not of the order of that particular range. As simple as that. Okay, again, one related example to your body. If you try to observe the thickness of your hair and try to observe even with the, you can say, vernier caliper, which is give you this much range, 100 micrometer. What is 100 micrometer? 10 to the power minus 4 range. Okay. Wait. 0.1 mm, which is 10 to the power minus 4 meter, or which is 100 micrometer. So obviously your hair is going to be 1, 2, 3 micrometer, more to more, max to max, right? Thickness I'm talking. So then again it is not precise. In example, a measurement of 5.328 meter is more accurate than the measurement of 5.3 meter because it can give you up to 3 decimal range. Only and only that particular instrument give you up to 3 decimal range. The particular instrument have that order. That order gives you until 10 to the power minus 3. Centimeter is till here. You can say 5.30 centimeter, but it can give you until millimeter. Clear? So what is the precision? Precision is the exactness or the precise value for any particular measurement. Exactness means how exact you are to measure that particular thing. Clear everyone? Clear na? Good. Okay. So that is done, that is done, that is done. Okay. Now errors in measurement. We done this na? So errors in measurement. Error is the difference between the true value and measured value of a quantity is known as the error of a measurement. Very basic formula or mathematically how we can represent. Mathematically. What happened to my writing today? Mathematically. Error. Sir, please explain last. Wait a minute. Error. Wait a minute, beta. True value minus measured value. Just a second, then obviously I'm going to. Yeah, this slide. What you want to ask? Tell me. Specifically, tell me. Precision or what? See, accuracy is how accurate you are to measure any particular thing. Precision is dependent on the instrument. If you are trying to observe millimeter thing with the meter range, so you are not precise enough, or you are means that particular instrument is not precise enough. If we try to observe the thickness of our hair, human hair, okay, human body hair, so obviously that is up to the range of 2 micrometer, 3 micrometer, and you try to observe that with the vernier caliper, or you can say centimeter scale. So that is not precise enough, that instrument. Is this clear now? So precision is the exactness of any particular measurement or refinement of any particular measurement, or it basically depends on the measuring instrument, and it is clearly mentioned here. It is basically describe the limitation of measuring instrument. For example, with the centimeter scale, we can measure only and only up to the range of 1 mm, not 0.0 or 0.5, 0.3 mm. Clear? In a same sense, vernier caliper gives you 0.1 mm, which is 10 to the power minus 4 meter, which is 100 micrometer also. And your hair length order or thickness order is 1, 2, max 10. Clear na? So that is why it is a precision. Okay. Then move up to the error. Error is why should I make this particular thing in a this mod sign, because sometimes or maximum number of times true value can be the low and measured value can be the high. For example, simple example you can take here. If you are going somewhere to buy a clothes, okay. Suppose you ask to buy a particular kind of garments, any particular thing, and that particular shopkeeper gives you 5.2 meter, somehow mistakenly. Okay, if you are not lucky enough, I mean, we as a customer not lucky enough to get this, but somehow. So obviously the true value you ask, it is 5 meter, and the you can say measured value of that particular shopkeeper gives you in a cloth to make any particular garment, that is 5.2 meter. So then the error is going to be negative. So to make it positive only, we apply the error. We apply this mod sign. But in general, error can be positive, error can be negative, error can be 0. Clear na? Why so and how so? If the measured value is exactly equal to the true value, that is 0. If the measured value is lower than the true value, it is going to be positive. And if the measured value is going to be higher than the true value, like in this particular example, so then it is going to be negative. But in general, other than this, there are other types of errors like systematic error, random error, or least count error. What is a systematic error? Where suppose you have a faulty instrument. Okay, there is a 1 mark missing. Okay, you understand in this way better. There is a meter scale or a centimeter, 15 centimeter scale. In this 15 centimeter scale, there is a 1 mark, or you can say 0th mark. 1, 2, 3, 4, 5, 6, 7, 8, 1. Suppose this is 1 centimeter. And here we have 10 divisions. So these are not visible, or these are not clearly mentioned. So that is going to be error which is systematic error according to the system, according to this instrument. And this is also known as instrumental error also. Random error is basically the human error, like you are not focused enough to take that particular instrument, to take that particular measurement, then it is going to be randomly. Or least count is dependent on the instrument again. Is this clear? First of all, tell me the error is clear to you guys, and then the types of errors. Then I can move ahead. Tell me with everyone. Okay, good. So that is systematic error. Now one by one we are going to focus what are these. So systematic errors are those errors whose whose cause are known to us. They can be either positive, or negative. Due to the known causes, these errors can be minimized. Systematic errors can be further classified into 3 categories: instrumental, okay, instrumental, observational, environmental. Now, what are these? See, first of all, systematic are those whose are known to us. For example, if it is a, again taking an example of a meter centimeter scale, if this particular instrument is faulty, so that is going to be instrumental error. So we know that particular error, and we can remove after taking the measurement. Clear? Fair enough? If you are measuring you can say length of this particular page of yours. Suppose you are finding example length of a page of your copy of the notebook, and that centimeter scale have instrument error, you can say 2 centimeter. Centimeter scale have 2, okay, let me change the color, have 2 centimeter, or you can say positive 2 centimeter instrumental error. So obviously, if you are, with the help of this centimeter scale, if you are observing the length of a paper, which is a L prime, is going to be 25 centimeter. So the actual length is going to be L, which is L prime minus error. Is this clear? And here beta L is, which is L prime 25 centimeter minus 2 centimeter. The actual length of your paper or of a notebook is L, is going to be 23 centimeters. So that is how you can find the actual length, because you know this particular kind of error. Is this clear? So the errors who are known to us, and we know the cause, so that particular error known as systematic error. Simple. Instrumental error. Okay, the first type is instrumental, the second type is observational. Now, what is the meaning of observation? taking an example of a titration. You are not doing the titration till now. What particular experiment you are done till now? Tell me, anyone. In class 10th, in the previous classes, what particular experiment you are done in your labs, schools? You have labs, na?
Yes, sir.
You have or not? Glass prism. Okay. So in glass prism.
Glass lab.
Okay.
I have slab, then prism, then lenses.
Okay.
And
So if what we observe in lenses basically.
the distance.
Distance. Okay. Good. So suppose you are observing a distance. Okay. You find the distance for that particular focus, right? If I'm not wrong, we are trying to find the focus of a lens. Am I correct? There is a long bench. One lens is going to be placed, one candle and upper side and lower side. I think that is the experiment. The same experiment. Okay, that is maybe in 12th then. So suppose we are trying to find focus. Okay. So focus length, or you can say focal length in general. We are trying to find the focal length. So here we have 8 students. So suppose Pranav, Pranav, Pranav observe that focal length f1 is 23 centimeter. He observed that. Okay. Then measurement of metallic bulb. Okay. Then the another student, Bhuana, she observed that f2 22.75 centimeter. Clear? Then another like Pradyuman Dubey. I'm going to write Dubeji. Is it clear? Is it okay, sir? P Dubey. F3. That is, he find a little bit more. 23.7, not 75 again. 23.05 centimeter. In so and so, each particular different student find each particular focal length. But the exact focal length is going to be, suppose, 23.50. Actual focal length, FA I'm going to write. Clear? Centimeter. So whatever the observation you guys are doing as an observation, so you know the actual is this and that is your one. So Pranav have 0.50 centimeter. She has more than that, and she I mean that Pradyuman Dubey have some 0.45 centimeter. You can say error in her or his observation, not her, his observation. Clear, everyone? Is this clear? So that is the observational error. Obviously, you are doing that particular observation, so there are chances so to get that particular error. The another kind of error, which is environmental error, I already introduced. We already talked a lot about it. You know that particular thing, like taking an example of simple to find the time period of a bob, which is 2 pi L by G. So with the changing environment, that particular G can be changed, because G is dependent on height, G is dependent on length of this particular thing, so many things. Okay, or maybe length can be changed according to the environment. Like I already told you guys, this length is dependent on temperature, dependent on your surrounding environment, or basically temperature. Environment, or basically temperature. And then G is dependent on environment also, basically height, depth, and so and so. So if anyone is going to be changed due to the environment, so the time period is going to be changed. Clear, everyone? So that is your environmental. Sometimes there is a, you can say, not cyclone, but a storm or a wind, a strong wind is going to be, and then due to that strong wind, or you can say strong rain, heavy rainfall, heavy sunshine, these are the factors also. But the main thing here is you know the reason, you know the cause of that particular error, and these are systematic errors. Clear, everyone? Good. Then instrumental error, going more deeper, like what is an instrumental error? So instrumental error, now I'm going to do a little bit hurry. Clear na? Because so many times I'm repeating this thing. So let's wrap up. Instrumental errors, these errors arise from the error due to imperfect design or calibration of the measuring instrument. Zero error in the instrument, etc. These can be reduced by using more accurate instrument. Example, temperature graduation of a thermometer may be inadequately calibrated. It may read 103 degree Celsius at the boiling point of water at STP. STP stands for standard temperature and pressure. Whereas it should read 100 degrees Celsius, because we know the BP. BP of a water is boiling point. BP of water is, we know this thing since quite long if you don't know. So I am telling you guys right now, 100 degrees Celsius. So the temperature of yours record 103, but it is accurate. We know this everything. Okay, so an inherent constant of a device, misuse of operators, effect of loading. What is the cause? Like instrumental error take place due to so many other. First thing, an inherent device means that particular device is not properly made. Second, misuse of operators, like you don't know the processor to use it, but you do some damage or something, so and so. In labs you are going to do. If you are not, so you are not doing experiment accurately. Because whenever we doing experiment accurately, we break something. I break so many test tube in my chemistry lab. Okay, so I'm not saying you need to break, but if you are not breaking, so you are doing the copy paste thing. Sometimes effect of load, or maximum, or you can say more number of times. Suppose if you are using one instrument so many times, so that is going to be faulty also. Okay, I give you the fourth one also. Long hours usage of an instrument. What is that meaning? If you are using, I mean, if you have single instrument and you are using so many times, and so many different kinds of students, one of the student, or you can say notorious mischievous student like me also using, so I can damage that, and then quietly I can place that up to the from where I get it, and then you are going to punish, not you, I mean my class fellow at that time. So you, I suppose you are not doing the same thing. If it is going to be faulty, so just mention that thing to your lab assistant. Okay, but you don't going to. I know this. No one is honest enough right now. I missed something if I'm not wrong. So that is environmental error. These errors are due to the changes in external environment conditions such as temperature, pressure, humidity, dust, vibration, or magnetic and electrostatic field. What is a magnetic field? What is an electrostatic field? You're going to find in the next class. But everything you know. If temperature is changed, pressure is changed, humidity, dust, like I already discussed, storm is going to come, heavy rainfall, snowfall, uh, a hot day, so that temperature is going to increase. Okay, so many factors is going to. If you measure your temperature under the armpits and during the measurement, if the electricity goes out and the room gets hot, it will affect your body temperature and affecting the reading. Wow, the best example I can get. Nice. Okay. Obviously, if in a hot summer day, if anyone is trying to observe the temperature and suddenly there is a power cut and you are not having any fan or AC in your room, so obviously your temperature is going to be rise. Clear? Okay, moving ahead. Observational error. These errors that arise due to an individual basis bias. I already mentioned that individual bias, lack of proper setting of the apparatus, or an individual carelessness in taking the observation. The measurement error also include wrong reading due to parallax error. What is a parallax error? Like in the last class, we talk about parallax method, like to find the moving objects with one theta, B, and A. So if any particular thing you are not finding accurately or correctly, so due to so many things like apparatus, individual careless, and due to this length or theta or angle, Basically, if you are not observing in a proper take care, so that particular error is going to be, and that is known as observational error. Clear? Clear now, everyone? Just type yes if it is clear, so I can move ahead a quicker way. Hmm. Okay. So now the second category is random error. That is important one. As we have the systematic important. Okay. There are three types of systematic error, and then in the same way we have a random errors. So the random errors are those errors which are irregularly and hence are random. These can be arise due to random and unpredictable fluctuation in the experiment condition. Example, unpredictable fluctuation in the temperature, voltage supply, mechanical vibration of experimental setups, etc. Error done by the observer taking readings. For example, when the same person repeats the same observation, he may likely get different readings every time. Okay, one simple example I can give you. Ohm's law experiment. Ohm's law. What is that? We are proving that Ohm's law with the help of this experiment. V equals to IR. Okay. So we are observing that particular graph. What is that graph? Basically, we are changing the resistance. Okay, we are changing the resistance with the same voltage. So, and that is your V equals to IR. What does that mean? That is your V voltage, and that is your I. Okay, and that the slope is your resistance. This. So, beta V equals to IR. We need to prove that V directly proportional to I means the voltage of any particular metal or of any particular conductor is directly proportional to the electric current. In reverse, how we can prove that? In reverse, we simply prove this thing with very basic thing. There is a wire, there is a wire and there is a rheostat box. What is a rheostat box? There is a changeable resistance. You can apply starting from 50 ohm to 100 ohm to 500 to 700, then 1 kilo, then so and so. So obviously then your I current in a wire is going to be V by R. And there is a circuit somehow look like this. There is a circuit look like this. In this particular circuit, simply, just a minute, just a second. Okay, in this particular circuit, there is a, this is what? Changeable resistance, the rheostat, RH. And here we have I. I means emitter basically. Emitter. And let's do this. Here we have potential difference, which is suppose V equals to 25 volt. So obviously whenever the current is going on, and that is the RH is VO state, changeable resistance, that you can changeable resistance. So the moment you change, your observation in emitter is going to change. Clear? Current or that particular emitter is going to give you different deflections. This one, according to your R, different deflection you get. But at the end you get the straight line. So what I'm trying to prove here, what I'm trying to say, what is a random error? Suppose again from you guys, if Samyukta is doing that, okay, So she is going to take the same thing. Everything is same, like emitter is same, rheostat is same, 25 voltage is same. But she observe the, you can say, this deflection in that particular. She observed that deflection in this particular ammeter according to her carelessness, sorry, according to her carefulness. How careful is she? Okay. If she is careful, so she observed the very accurate. For example, if the deflection is showing, you can say 20, not 25, suppose 15.02 milliampere. So she gonna write 15.02, then 15.04, then 15. Okay, obviously I need to change the current because resistance is 10.03, then 5.060, and everything in milliampere. What I'm doing, resistance in first time is less, and then high, then high, and then high, and so on. So clear? Now instead of Samyukta, Sara is doing. So for same everything, for same resistance, suppose this is going to be, I'm not going to give you the mathematical clearance, but suppose it is 10 kilo ohm, that is 5 kilo ohm, that is for 1 kilo ohm. But another student for same thing is going to observe something different. So that randomness, the moment you change the observer, or that randomness, even if you are doing yourself again and again, okay, now you are taking these three readings, Samyukta all alone, at time period of 10, which is, you can say, 10, uh, 10 means 10 in the morning, 10. Okay. After 2 hours or after 1.3 or so many, we can say 1 hour, 2 hours, if she is going to take the same reading, I mean, if she is going to take the reading with the same apparatus or same everything, like resistance and wire and voltage, so obviously the fluctuation is going to be, instead of 5.02, she now going to observe 5.04, 5.20 maybe. Instead of 10.03, it can be 10.34, something else. So that is random error. Okay, based on the individual, based on the instrument also, and so many stuff. So these are not known to us, first of all, because it is random. They are coming irregularly. So these errors are known as random error in general. Is this clear, everyone? Is this clear, beta? Because in the next, right now you are seeing theory, theory, theory. In the next lecture, you are going to see example and numerical, numerical, numerical. Okay. So this is gross error. This category basically takes into account human oversight and other mistakes while reading, recording, and readings. Okay. The most common human error in measurement falls under this category of measurement errors. For example, the person taking the reading from the meter of the instrument may read 23 as 28 gross error. What is the meaning? Like 28 is a look-alike of 23. Clear? So instead of 28, you read sometimes, and it is happened to me right now, just before your lecture. What happened to, I mean, I tell you the latest story of today. Your lecture is going to start at what? 7:30. Clear? At 7.22, I think it is 7.32. But I am talking to some other faculty, and at their screen I see this 722, and I thought that it is already 7:32. Then the other faculty told me, no, it's 7:22. You have still 8 minutes. So that is a gross error. Like, it is somehow look alike to this, and you read something else. Clear? Basically, it is a human error which going to be arise whenever you read or mislead with the same look-alike things. Clear na? Is this clear, everyone? Good. Okay. So these are some points which you need to take care. So proper care should be taken in reading, recording the data. Also, the calculation of error should be done accurately. By increasing the number of experimenters, or you can say experiments, we can reduce the gross error. If each experimenter takes different reading at different points, then by taking the average of more readings, we can reduce the gross error. It is going to be general, not only for gross error, but whenever, like, there that is the science of taking so many readings for simple experiment. Like, you maybe you ask till now or don't to your lab assistant why you take 5, 10, 7, 8, 9 readings for the same thing. Because whenever you're going to take readings, there is 100% surety that the error is going to come. If you are not having an error in your instrument, you are doing copy paste, as simple as that. And that one thing is taught by my teacher in the graduation, not even in schools. One day what happened, I make the most accurate graph. She never ever seen that particular graph in last 10 years. She caught me in a minute. The moment I saw her, she caught me in a minute, because you cannot make this particular graph if you are doing properly. If you are done in a real. She said this exact line to me. And then I don't have any option, because she know better than me the condition of that lab and instrument and everything. Then she tell me, beta, if you are copying paste from anywhere, from yourself, from Google even, there at that time Google is not going to help us, because we don't have that much amount of data or something. So she told me, like, if you are trying to make me fool, do with it brain also. You can't just come directly and said like I'm done with the graph. Then I realized if you don't have error in your readings and your graphs, so you are basically doing the copy paste, and it is quite accurate, because they know that particular instrument is used since last 15, 20 years, or at least 15 or 10 years. So that particular instrument have some error automatically, isn't it? Right now, your school also buy that particular instrument maybe minimum to minimum 15 or 10 years ago. Any particular instrument I'm talking right now. And if your school or organization buy right now, you are so lucky. Believe me on this. You are lucky enough in this. So that is why we take average. So that is simple question. A spectrometer. What is a spectrometer? Spectrometer is a device which is going to help you out to see the distant object. Okay, a spectrometer gives the following reading. When used to measure the angle of a prism, main scale reading is this 58.5 degree. Vernier scale reading is 0.9. Division on a main scale correspond to 0.5 degree. The total division of the vernier scale is 30, and match with 29 division of the main scale the angle of the prism from the above data. Obviously, did you guys know about vernier scale till now? So that question I need to tell you then directly without taking a minute. Okay, so what is a vernier caliper? Vernier caliper is nothing. Okay, I'll show you what is a vernier caliper. Just a minute. Vernier caliper images. Just a minute. This is your vernier caliper look like. You're going to see in your class 11, 12 in the lab, obviously. So this is vernier scale. Okay. This is your vernier scale. This is the main scale, and this particular reading is going to match with this main scale. So this is what they said. Okay. This is internal jaws. This is what. Okay. Suppose if you are trying to find the radius of this small ball, so you need to pick in this, and then obviously when you get the diameter, so you get the radius also. Is this clear? That is the first use. if you try to find the radius of a tube, look like this. Okay, this is your. So now this internal jaw is going to fit into there, and obviously this internal jaws gives you the again radius of this. So majorly the radius or the length of very fine thing you try to find with this instrument. Clear everyone? What is a vernier caliper and the use? Vernier caliper. Okay, and one basic or one realistic example I can give you. In each particular automobile industry, there are small nuts and bolts going to be attached, because that particular car, bike is going to attach, or you can say instead of attach, it is going to ensemble with so many different parts. Okay, like engine is going to made separately, headlight, then handle, then the wire, the wheel, and so. If we are talking about the car, the gates, or then seats, and then you can say handle of that particular car, steering, you can say. So everything is going to be assembled or installed or assembled with the help of small nuts and bolts. So these nuts and bolts somewhere they built in any particular farm or some small industry. So there you directly use that to measure the length, because if the precision is not going to match, suppose you instead of that much small length, we can say suppose instead of 1 mm you make a bolt of 1.5 mm. So within a minute, not even within a minute, within few seconds, that wheel is going to be coming out from the car or bus or something, and then there is a major drastic accident is going to be. So obviously, in installing this particular kind of thing, they recheck again and again so many times to pass that particular thing, like that is actual thing which we're going to use. And then even after that, there is a testing is going to be. Okay. So in real life, that's how these things are going to be used. Okay, moving ahead. Least count is main scale division. That is the formula we're going to understand in great detail. But what is the least count? Main scale division minus vernier scale division. So here, main scale division is 0.5 degree and 30, and vernier scale division is 29 main scale division. So least count is going to be 29 by 30 into this much. So least count is going to be 58.65 degree. Okay, this is going to be done again when we are clear with the concept of this least count and instance. Okay, because right now you are not going to understand. One basic thing I can give you: least count is the minimum possible value with which with this particular instrument you can find out. Okay, and to find the error in this, there is a formula. Least count basically main scale division minus vernier scale division, where main scale division is this 0.5 degree, and how much it is going to match, like this particular 29th scale is going to match with the 30. So that is the vernier scale. So least count is basically LC, main scale division minus vernier scale division into that main scale reading, MSR. So that is the least count. So main scale division here is 0.5 degree minus, it is going to match with the 29 out of 30 into 0.5 degree. So that is how you can calculate your least count, LC. Is this clear with everyone? 58.65. Obviously, it is not in a proper way. So once we are done with this LC and so we are going to do that again for a question like this. Clear everyone? If you are not understanding, it's okay too. Find this. The current voltage relation of a diode is given by this. I equals to this milliampere, where the voltage V in the volts, temperature T in the degree Kelvin. If a student makes an error measuring this much in voltage, the current of 5 ampere at this Kelvin, what will be the error in the value of a current in milliampere? Okay, first of all, tell me what is the meaning of this question. Anyone understand this? Because this is exactly JEE or NEET level. Tell me, Vitta, how many of you understand the meaning of this question? Solving is separate thing. If you are not understanding, so that is not going to help you out. Tell me, everyone. Sara, Samyukta, Shrita, Pranav, Pradyuman, Bhuvana, Mokeshwaram. Because obviously you join this particular batch to clear some entrance exam, and in entrance exam we face questions like this. So tell me how many of you guys understand this? Not understand. Okay, not understood. Everyone? Or anyone understood this? Pranav, beta, you, or Mokeshwaram, are you? Anyone, if the basic thing. Okay, see, first of all, diode is not a, yes, sir, not able to understand. Good. Not understood. Okay. See, for till class 10th, we see that there are few materials which are known as non-ohmic. So diode is non-ohmic, in which V directly proportional I is not going to function. For non-ohmic. Clear? For non-ohmic materials. And diode is one of them. Semiconductor. This thing at least you know. Diode is a semiconductor, right? What is a semiconductor? A material in between conductor and insulator. Okay. So here the relation is given I equals to e to the power 1000 V by T minus 1. There is some relation in between current and voltage. So obviously if I have a error in measuring voltage, that is the error. This is my voltage here. So obviously I can get the error in finding this, isn't it? Simple thing. It's like there is a relation. In that particular relation, if I have error in something which is given to me, so whatever the thing I find, I try to find, that is I going to be not error free, that is going to be with error. So what is that error? That is I want to find. The question is clear to you or not? Again I am saying, suppose there is a length and I have a meter scale. In that particular meter scale there is an error. So how many number of times or in how many attempts I try to find this particular length error free? I cannot find error, as simple as that. The same thing is given in the question, but in a typical language, in a typical physics so-called language. Okay, that's why where most of the students have the problem with the physics. It's not a new thing. I can hear this thing since so long. So it's not a big thing. First of all, whenever you see any particular question, try to understand it. What is the question needs to solve that. Okay, what that particular question is asking to you. So simple thing. Now you get it. This relation is given to you guys, and there is an error in this. This is what voltage. So if obviously if we have a error in this voltage and this current is related to the voltage, so we get error in current also. So that we want to find. Clearly mentioned here, if you focus, what will be the error in the value of current in milliampere? Because why so? There is a current observed in milliampere, so you cannot get the current error in ampere. It is not going to be. If you finding a measurement in centimeter, so the error is going to be in centimeter. Clear na, Pradyuman sir? If you find any particular measurement in centimeter, so the error is in centimeter. To observe the length from one state to two state, which is in kilometer, 100 of kilometer, you cannot say there is a 200 meter error. There is an error in kilometer also. So the same thing. Is this clear? Understood everyone? Question what it is? I hope and believe everyone is understood what the question wants to you guys solve. So let's, given I is this milliampere. Now I plus 1 equals to e to the power. Okay, what is the process here? Very easy, very simple. I is e to the power 1000 V by T minus 1. So I can do that I plus 1 e to the power 1000 into V divided by temperature. Is this clear till now? Is this clear now till now? If I differentiate with this equation, this is my equation 1. If I differentiate this equation, so di, what I differentiate? I try to find the error which is in I. So that is di, change in I. Plus 1, it is a constant, so it is not going to differentiate, 0. di equals to 1000 upon T, e to the power 1000 upon T. Better that is differentiation. You can ask the maths teacher, dv. What is simply I am trying to give you, if you have a relation x equals to e to the power y, e to the power y k, y by k. Okay, so dx, change in x, gives you y by k, e to the power y by k, change in dy. This change in dy is the error in y, this change in dx is the error in x. As simple as that. Okay, more deeply about this relation of differentiation, the maths teacher can teach you. Clear? Is this clear till now position we are reached only? So now di 100 upon t, which is 1 plus 1 dv. Why so? Because this e to the power 100 by e to the power 100 v into t is 1 automatically. So this is just putting the values, and dv is the error in voltage. This is already given to you guys. So just putting the values, temperature is given, and then if you put the value of v also, so you can get 6 and then 1, so you can get di. I mean change in or error in. See here in this okay, wait. In this equation number 2 you have everything. Back to the question. See, you have voltage, you have 300 Kelvin temperature also, you have error which is 0.01. Okay, and what you need other than this? Nothing. Clear? Is this clear? Tell me, beta, is this clear or not? Just putting the value here, you can get the answer, and the answer is di, change in, or you can say error in current is nothing but 0.2 milliampere. And what particular is C. So the exact answer is C. Clear? Okay, moving ahead. Because in the coming slides, most of the times, most of the time an example or a question is going to be. Okay, so let's discuss this. So what is an estimation error? You just going to estimate, you can say approximate value. So estimation of errors, there are 3 types of errors, like absolute error, or absolute mean error, or you can say relative error. And then with the help of relative error, we have a percentage error also. So this is the first estimation error. So absolute error, what is that? Okay, important one also. All this important. So what is an estimate error? I mean absolute error. The difference between the true value and the individual measured value of the quantity is called the absolute error of the measure. For example, suppose a physical quantity is measured n times. What is the meaning of this, beta? Suppose time period. Okay, let's stick to the time period in the next slides. Time period of a pendulum. Time. Okay, instead of this, very basic thing. Time period. Interesting. I can make this experiment. This time period of a blinking of an eye. Okay, blinking of the eye. Clear? So you have a group of 4-5 people. Suppose right now we are doing this. We have seven people, seven students. So any one particular taken as an experimental body. For example, suppose Bhuvana. Okay, so Bhuvana, how many number of time? I mean, after each particular second or after how much second she is going to blink the eye. So we are going to observe the time. Is this clear? That is accurate, na? We can do that. So every particular student here is going to give me the different values. And believe me if I'm saying, I mean that is going to be. So suppose Pranav take 10 observation and that after 10 observation, the arithmetic mean of the 10 observation is AM. Now, why we find this arithmetic mean? Because we are not exactly know what is the accurate time whenever she is going to blink. Suppose in first observation, the Pranav is finding suppose 2 seconds. In second, 2.3. And then in third, maybe the time range, she is continuously stare at him. It is going to shoot up 3 seconds. But suddenly after that, that is going to be 1.78 seconds. Okay. So in this way, the 10 readings is going to be. Now Pranav is confused which one is the correct. So obviously we take a mean, and after taking a mean, we're going to find the error in each of the, you can say, particular measurements. Is this clear? Is this clear now? So if the true value of a quantity is not given, because you don't know the true value, that is dependent on the individual, like Pranav is finding in the range of 2 or 3. Maybe Samyukta is going to find in the range of 4. Or you can say 1. Maybe Sarah is going to find in the range of 5. Clear na? So that is when you don't know the true value. So we do the number of experiments or basically measurements, and with the help of these measurements we find the mean value first, and then with the help of mean value we find the error. So if the true value of the quantity of the given quantity is not given, then mean value AM can be taken as a true value, and once we know the true value, then the absolute errors in the individual measured values are A1, I mean error in first observation, or you can say A. That is error in first observation. True value, which is mean, minus A1. Similarly A2. Similarly so and so n number of times. So the arithmetic mean of all absolute error is defined as the final or mean absolute error, that is error mean or del A. So first of all, what is absolute error? Absolute error is nothing but when we don't know the true value, so the mean of value minus individual value. That is your absolute error. Is this clear, everyone? Absolute error. Now obviously that error is going to be very large. Suppose it is going to be 0.75 second each time. So now you are, I mean most of the number of times. Now you are going to find in a first time it is going to be del A1 that much. Del A2 it is going to be 0.55 second. Del A3, I mean absolute error in third observation is going to be 0.45 second. Now you again confuse which one is going to be taken as a error, actual error, because you don't know the actual value first, and now the errors are so bizarre, or you can say so uh, different in each other. So then what you are going to do? Arithmetic mean of absolute error also. So that is taken as the actual error. So del AM arithmetic mean, okay, arithmetic mean of all the absolute errors. Absolute errors. And that particular error we take as a true error. Clear? Fair enough? And this particular formula, this particular formula number 1 here, very, very important. Because most of the time, you need to find absolute mean error. Is this clear? Or arithmetic mean of absolute error. Then there are two terminologies named absolute mean error or sometimes mean of absolute error. The same thing. Is this clear, everyone? In a same sense, you can do any experiment other than this. Instead of blinking of eye, finding the height of a person. Okay. In finding the height of a person, the same thing you're going to find. You don't know the actual height of a person. If suppose I am not telling you the actual height of a person, so the same problem is going to be arise. So first of all, like in the previous page, we find the first of all arithmetic mean of all values. So that taken as a true value. Then from this particular arithmetic mean, we're going to find the error of in individual value, and then arithmetic mean of all the errors. So if the measured value of quantity be A and the error in measurement be del A, then the true value of A1 can be written as A plus del A. That is the main thing. Okay, is this clear with everyone? If it is not, so I can go slow a little bit. I think it is quite a good place. True value in first measurement in blinking of an eye experiment. Okay, A1 is nothing. A, which is mean, the true value, plus minus. Why should I make plus minus? It can be it can be positive, it can be negative. So that is the true value in first measurement. Is this clear, everyone? Clear now, everyone? Okay. Good. So moving ahead. Now, if you clearly understood the absolute error, absolute mean error, or you can say arithmetic mean of absolute error, then the this relative or fractional error is very easy. So this is your second type, relative or fractional error, and that is percentage error, and that is very, very important, both the things. Just a minute. Okay, why it is very, very important, you're going to see in a minute. Now relative error, it is defined as the ratio of mean absolute error del AM to the true value or the mean value AM of the quantity measured. For example, the relative or fractional error, as it is, why it is telling, why the name is given relative, very easy to understand. Suppose suppose you are going in somewhere, a party or a function, right? So suppose you are going in your father's side. So whosoever the relative is going to meet to you, they ask you according to your father's name or on behalf of your father's name. Are you the son or daughter of that particular student? That particular person. Clear? Isn't it? Or if you are going in a school party, in this way you can understand more better. So then any particular person is going to ask you which particular section or which particular class you belong, like 9th A or 11th C. So that is the relative. In that particular relation, you are known to them. Or suppose if you are going in intra-school participation, debate, sports, any particular kind, okay, art, science, any particular thing. So there they ask you like which particular school you are. So then in the relative of school you are represent, and then on the behalf of class also, the standard also. In the same manner, this relative error or fractional error is give you the error on behalf of the true value. Which is the true value here? What is the true value here? Basically the mean value, because the true value we don't know. Clear na? So when we don't know the true value, so how we can give the relation or fractional error on behalf of that? Simply mean value and mean absolute value. That is very, very important. Okay, relative or fractional error. And when you multiply 100 in relative or fractional error, you get percentage error. So when the relative error is expressed in percentage, it is known as percentage error. So obviously, percentage error is relative error into 100. Percentage error simply sometimes in this way, percentage error, not sometimes, majorly in this type. This is your mean, absolute mean of error, and that is mean of value into 100. So this relation is important also. Okay, and instead of this, how it is going to be more? This is your percentage error. This is relative error, and that is into 100. So these are the things. Okay. So first of all, understanding the absolute error, then related to absolute error, relative error. Sorry, then understanding absolute error, then after absolute, arithmetic mean of absolute error, then the true value of first measurement or any particular measurement, and then in a simple way relative error as well as percentage error. Is this clear? All the three things, because these three types of errors are more important. They are more frequently coming in your numerical portion. It is clear? Everyone other than Pratibhan Dubey also. Is this clear, but everyone? Clear now? Mukeshwaram, Saraparna, Bhuvna, Samyukta, Shrita or Ashrita. Good. Okay, so these are two, three, you can say formulas. You can mark it out, an important thing. So this one is very, very important. Again, this one is important too, or very important. The below one is also very important. So this one is a numerical behalf on that, and based on the previous thing. A student measure the length and width of a rectangular sheet of a paper, 30 centimeter, 20 centimeter. Respectively, the absolute errors in the measurement are determined to be 0.2 centimeter and 0.1 centimeter. What is the absolute error in calculating area of the sheet? So area is length into breadth. Error in the length, error in the breadth, you just need to multiply. That's it. Do that quickly. I'm not going to tell this. This is very easy. I already give you the hint. Area is length into breadth. So obviously find the length into breadth first, and then okay, error in multiplication is going to be added down. So now give me the answer. Okay, hint is in multiplication of quantity. In multiplication of physical quantity, errors going to be added down. So tell me, what is the error? I think after writing this, you don't need to see the even this what it is. What it is? Answers, or you can say options. Tell me which one is the correct, beta. Seriously, you take that much time to give me the answer of this. How are you going to clear NEET J? Speedily, do that. After that, I am going to teach you, and then propagation of error. That is nothing. Error in addition, error in subtraction, error in product, or error in division. That is known as propagation of error, and then error in quotient. That is the important thing. Or in product of powers. Nice. Tell me, beta. Option B. Everyone. Pranav, you tell me why you. I mean, is this clear? Why B, not C? Because 0.3 also. See, B is because it is the range or it is the unit centimeter square of area. Simple thing. To calculate the area of a sheet, length into breadth, the error, absolute error in the area can be determined by adding the absolute error in the length to the absolute area in the error, absolute error in the length, absolute error in the width, 0.1, 0.2 centimeter. Therefore, the absolute error in the calculated area of the sheet 0.3 centimeter square. It cannot be 0.3 centimeter. Clear? Simple thing. Okay. This is given x equals to a b square upon c to the power 3 if the percentage error in a, b and c are 1%, 3% and 2%. Respectively the percentage error in x. That is very easy. See, whenever you get this kind of questions, so what you need to do, whatever the order, okay, I am going to show you, right? Maximum percentage error in x is del x by x into 100, which is del a, change in a upon a, which is error in a, to how it is come, because when we do the differentiation of x, dx by x, that is how we do that. So change in a, error in a plus 2, this power comes down, plus, because it is going to be give you minus 3, but in errors we added down everything, and that's we're going to find in a minute in next slide. So now error in A plus 2 times in error of B plus 3 times in error of C, and that gives you error in X. And now multiply, so that is simply percentage. So 1 plus 2 into 3, that is 6, plus 3 into 2, that is 6. 6, 6, 12 plus 1, 13. So that is 13% error you get in X. That is A option. Okay. Is this clear? We just need to differentiate it. Is this clear, beta? And okay, if you guys don't know the differentiation, I'll tell you one simple formula. Because differentiation itself a drastic thing, or you can say big thing. If you have a power of x to the n, okay, and so you can differentiate x in the change of x. So dx, okay, not in this. Wait. Suppose there are two variables y, x to the power n. Clear? Any particular function y is related to the x, which is power of n. So now we want to see the change in y when we going to see when we going to do the change in x. So dy by dx is nothing but n x to the power n minus 1. Means what we are doing here, we are observing the change in y when we are doing the small change in x. Simple. And that is your formula for what? Formula for differentiation. Is this clear? I know I cannot formula for differentiation. In chapter assessment, what is a chapter assessment? After the, next class, the chapter is going to be finished, and then I teach you the differentiation in basics. Right now, you just noted down this formula. Difference, not differentiation. What is the differentiation? What is an integration? PIATI differentiation. Okay. Right now, you focus on this. So based on this focus, I want to find the change in x, del x by x. So I can do del a by a plus 2 into del b by b plus 3 into del c by c, which is del c by c is the error in c, del b by b is the error in b, del a by a is the error in a, and it is given 1, 3 and 2. Is this clear? Clear now everyone? Good. Moving ahead. Now this is very important again. See, till now you are going to think in your mind, sir, each particular slide going to write very important, very important. Obviously, this particular whole class is very important. Okay, till now, what we already done in this class, because it is going to be a little bit extended maybe, or till last, and then you need to do CA by your own, and we're going to discuss in the next class maybe. So, till now, what we are done in this class, 2-3 things. What is error? First thing, okay, then how many types of error we have, second thing, and okay, so first thing we do, what is error, second, how many types of error, different terminology or definition of error, and then the fourth important thing, arithmetic rules and regulation apply on error. So how your error is going to be behave when you are going to add, subtract, multiply, power, quotient, that we are going to discuss. Clear? And each particular slide in a coming slides is going to be very, very important, because till now you are just understand like this. There is a song is going to be coming out. Till now you are just understood the teaser of that particular song. The whole complete 5-6 minute song is still there. Samyukta's face expression like shit. This is the teaser. I can feel you. If this is the teaser, I didn't understand that much. So how it going to be the song or the album, isn't it? That's how you thinking right now. Don't worry, in the chapter assessment, I can repeat this everything. Meanwhile, the formulas related to this, I can explain. Okay, you don't need to worry about it. So, okay, don't worry about it. Once you see this particular lecture at 0.75 speed or even in the normal speed, you're going to understand each and clear stuff. But I know the few mathematics stuff you understand more clearly when you done the at least differentiation. Nothing more than that. Okay. So suppose suppose the result x is obtained by addition of two quantities, say A and B. Again, you can say perimeter. That is the best example I can give you. As we know, there is a length and there is a breadth. So beta perimeter is 2 into L plus B. Same thing, right? X can be obtained L plus B. The length and breadth, A and B. Now what if we have an error in A or error in B, or the instrument we are using obviously going to give me the error in length and breadth both. So let A and B are absolute errors in the measurement of A and B, and del X is be the corresponding absolute error in X. Then obviously just del P is the absolute error in perimeter. So the reading is going to be X, or you can say the actual perimeter is X plus minus del X, A plus minus del A plus B plus minus del B. Okay, doing the whole mathematics. So the error in A, or you can say error in this perimeter, is nothing but error in your length plus error in your breadth. That is the simple case. Is this clear, everyone? This equation number 1 is simple. Nothing more than that. Clear na? Obviously, if you are like in the previous question, in this particular area question, we are doing the same thing. Clear? We know the error in length, we know the error in breadth, so we cannot going to do the product, or even if you, because error in product is going to be added down. In the same way, error in addition is going to be added down. So that is the simple first case. Is this clear, everyone? Clear? Clear na? Okay. Clear then. Then moving ahead, error in subtraction. Now, even if it is a subtraction, even if it is a, any particular thing you're going to get as a subtraction or as a addition, the error is going to be added down both the time. So that is the simplest thing. So whatever the mathematics we are done in the previous, so x is A minus B. Again, del A, del B are the absolute error in the measurement of A and B, and del X be the corresponding absolute error in B. So X plus del X, A plus minus del A minus B plus minus del B. That is the scientific way to write any particular measurement. Like we write A1 is, you can say AM, which is the mean, and then error, absolute error in 1. In the same way, for A we can write in this way, for B we can write in this way. So beta, the error in X, either it is going to be your physical unit in a subtraction way, in an addition way. Thus, the maximum absolute error in X is maximum absolute error in A plus maximum absolute error in B. Means whenever you're going to find the absolute error in any particular quantity, it is not mandatory, like it is obtained after addition, it is obtained after the subtraction, the error is going to be added down. So this is your question, important formula number 2. One basic thing till now we understood, error is going to be added down. Clear? Even if your physical quantity is going to be subtracted. Clear everyone? Good. Moving ahead, now the major thing is going to be, suppose the same thing we're going to follow, nothing new, but my physical quantity, suppose momentum, mass into velocity, right? Simplest thing, you know this thing. So in the same way, X is A into B. It can be any other quantity also, but for right now we stick to this momentum. So if we have an error in mass, which is del M, if we have an error in velocity, which is del V, so the error in momentum del P is again del M plus minus del V, nothing more than that. Again, important third rule, error in product also, error in multiplication also is going to give you by the added terminology. It is going to give you by the addition. So that is your third, and that is your important idea. Is this clear? Don't confuse yourself in the mathematics right now. We are not interested in finding this, you can say momentum. We are interested in finding the error in momentum. Clear na? So what we are understood till now, either my particular physical quantity is going to be given by addition, either subtraction, or either you can say multiplication. In each particular kind of things, the error is going to be the maximum, and when you get the maximum error, whenever it is multiplication. Simple that. So let A and del B, del A, del B the absolute error in measurement of A and B, and del X is the corresponding absolute error in X. So X plus minus del X, A plus minus del A into B plus minus del B. So multiplying, doing everything, this is your error. Now, where from this comes? Obviously, this is have a formula A plus B to the power 2. Okay, so how it is? A square plus B square plus 2AB. Okay, I'm forget here to write this thing. Just give me a minute. Plus minus error in M, error in V. This is the advancement here. Okay, this is the advancement in this formula. Okay, so this one is third important. Clear beta? In multiplication, the advancement is we not only add the errors, but we multiply the errors, and that particular multiplication is also added down to find the error. As you can see, del A, A plus del B, B plus del A plus del A plus del B, or you can write directly this thing also. That is the same thing. Because if you are going to multiply with A plus del B, obviously that is going to be given by the error. Is this clear, everyone? Error in A, error in B, plus the multiplication of both in both the errors. The major thing, the drastic change you're going to see in division or okay, or in quotient, or you can say, should I teach you that much? Wait, wait, wait. Okay, do one thing. This I am not going to do in a hurry. Do your test right now, or if any particular question related to the this thing, so we can do after the this class. In this only page number 26 we are doing, not more than that, because the other incoming things are more important, and I am going to teach you in next class. Clear? So try to attempt this particular class assessment. I am going to help you out. If you are not able to do that, obviously I am going to help you out also. Do this test assessment, because I can teach you in next 12 minutes, then I need to be in so hurry, and I don't want. That is important. Till now, okay, let me see also in which particular test question of yours. First one is easy. Second one is a little bit tricky. Third is also. Fourth is easy. Fifth is easy. And then sixth is easy too, if you get the idea till now. See, the maximum number of questions are based on this, but still if you feeling like you are not able to do that, so please let me know which particular question you are facing problem. Click on this. Okay, see, I can teach you in next 10 minutes also this everything, but I don't want to, because then you are not going to understand, believe me on this. Okay, so here we have a test, like now. Click on this. There is a test, and you get a test naming errors in measurement J3. In the next 10 minutes you're going to try that. There are 6 questions if I'm not wrong. In the given 6 questions, each particular question is related to till now what we have done, but still if you find something you are not able to understand the particular type of question, so let me do that. Okay, next 3 things I am going to just give you a brief. What are these things? In the next, proper finding of error in product and division, then quotient means powers, and then how to deal the error in power. That's it, nothing more than that. Only 3-4 pages are there, but these 3-4 pages are worth 30 minutes, and I don't want to teach you in 10 minutes. I can, but I don't. Clear? I think for you guys also I need 2 over 30 minutes class, because I feel this. In 11th class I need to explain more as compared to the 12th class. So many things you are here very first time. So that's why I feel like I'm going to raise this query, at least for my side. This is clear, because here we teach 2.5 hour or you can say 150 minutes for NEET and JEE aspirants. So why don't we give you? Or maybe this is not because right now you are not able to digest direct 2.5 hour class. Because in 2.5 hour I teach till 140 minutes. Just 5 to 6 minutes break. That is very drastic for students sometimes. Like, why you teach this much, that much? And if I teach 140 minutes, so that is almost 3 hours thing for you. as a student. Okay, do that. If you find any particular numerical you are not understanding, if you find anything you are not related to the course till now, to the particular class in error till now, you can ask me. Feel free to ask. And if you find, so we can move ahead a little bit more. Okay, just make a glance in the next 2 to 3 minutes. If you are thinking you are able to do that, all the questions by yourself, so at least 2 pages I can cover in next 5 minutes. And if you think you need my assistance in any particular question, so let me know. One small data I want to share in the beginning of your journey of NEET and JEE preparation. You only get 2.5 to 3 minutes to solve any question for both the examination. So start preparing or start doing preparation in this way since beginning. Time is the key, or you can say time is the most important thing in any particular entrance exam. If you know how to manage your time, you can clear any particular. If you don't, I don't want to say this, but it is the harsh reality. If you are the topper of your school or of your state even, you are not able to clear entrance exam because their time management is lacking. That is the hardest or worst truth you can hear from any particular teacher. Okay, don't feel sad and bad about it. You are you have you can say very long path to go ahead. Just do mistakes and just do n number of questions where the n can be very large, extremely very large. The more you do practice, the more you are get closer to your goal. And try to write as much as possible in solving the questions. Clear? Because the more you write with the pen and paper, the more you do the calculation in your head, the more your brain is going to be functioning. Because if you try to click or if you try to do the calculation like 35 into 3, which is 105, okay, so then you take more time. And as I already told you guys, time is the most precious thing in any particular entrance exam. Is this clear, everyone? Should I move ahead? You can do that questions by yourself now. Okay, so at least 2 pages I can cover. Then I need to cover a little bit less in the next class. So that is the propagation of error in product. Continue through this dividing equation 2 by 1, where the equation 2, this is your equation 1, means the particular physical quantity, for example momentum, and this is your equation number 2. Okay, let me highlight, this is your equation 1, this is your equation number 2. So dividing equation 1 by 1, 2 by 1 to get the absolute error, or you can say to get the relative error in this particular momentum thing, del P by P. This is your, so simply del B into del A upon AB plus minus A into del B upon AB, and this del A into del B divided by AB. So that is how you can get your error in more than 2 quantities, because right now my quantity is dependent on only 2. But if in any case it is dependent on 3, for example work done, or simply for example force. How force is dependent on 3? Simply you can see that mass into acceleration. What is mass into acceleration? Mass into change in velocity point. Clear na? Now it is dependent on 3. So for that particular thing, this formula number 3 I already given to you in the back then. So this formula number 4 is going to be important. The quantities del A by A, del B by B, del X by X are called relative errors in the values of A, B and X. The product of relative errors in A, B, that is del A into del B, is very small. So we can neglect it. Simply as we know, suppose del A is 0.02 centimeter and then del B is also 0.04 centimeter. Multiply that. So that is going to be up to the range of 8, which is 0.0008 centimeter. Very small. So we can neglect this. The moment we neglect this, then we get the same thing. Del x by a, del a by a plus del b by b. What is this? Absolute error in a plus absolute error in b plus absolute error in the absolute error in my quantity, which is x, which is momentum I can take here, which is del p by p, is absolute error in m, which is mass, plus absolute error in velocity, which is velocity v. Okay, so now we come to the same point. Even in product, even in wait a minute, even in product, even in multiplication. Sorry, I am doing this. Even in product, even in multiplication of quantities, physical things, we can get what it is, like the same thing, addition. Moving ahead, propagation of error in product. Okay, from now in the next, from this we are going to do in the next class. Page number, slide number 28. Since slide number 28. In next class, because I don't want to teach now within a minute or two. Even that is not going to be. Okay, I just give you a brief hint. See, propagation of error in product, so you can get the same thing, maximum error in A, maximum error in B. Then propagation of error in quotient, that is very, very important. Okay, and then propagation of error in quotient continually, continuous, then this, then this, then this, then this, then this. So many things going to be. So that's why I don't want to do the rush. At least 10 pages are there, and then 10 pages are important enough. Clear, everyone? Clear now, beta? So these 10 pages we cover in a recall in the next class, which is going to be on Thursday, if I'm not wrong. See this particular lecture whole again. If you get an idea, so try to get an idea for differentiation at least. Okay. Read little bit about differentiation. That is going to help you out. From YouTube, from everywhere, or sorry, from anywhere. Differentiation. Okay. Okay, beta. So that's by my side.